A car of mass 500 kilograms experiences a constant resistance to motion of 450 newtons. The car is travelling at 40 meters per second. We want to know what braking force is required to reduce the speed to 20 meters per second in 5 seconds. Consider the diagram. The car needs to accelerate in this direction since we want to slow it down from 40 meters per second to 20 meters per second. There is a constant resistance to motion of 450 newtons, and we must also be applying a braking force to the car. We'll call it P. The weight of the car acts downwards, and there is a normal reaction force. These forces must be in equilibrium since the acceleration is purely horizontal. Now consider this information. This is SUVAT information and enables us to work out the acceleration. So write down SUVAT, 5 seconds to reduce speed from 40 meters per second down to 20 meters per second. We want the acceleration, and these four quantities are linked by v equals u plus at. So 20 is going to be 40 plus 5a, minus 20 will be 5a, and so a is minus 4 meters per second squared. We can now use F equals ma. We know that the vertical forces here are in equilibrium. The resultant force acting on the particle, therefore, must be the P plus the 450. That will be equal to the mass, which we know is 500, times the acceleration, which is 4. We don't need to worry about the negative. The negative told us that the object was slowing down, and we've already drawn that on the diagram. The A acts in the same direction as the P and the 450. So if we say that the P and the 450 are both positive, then the 4 will be positive as well. Continuing with our calculation then, P plus 450 must be equal to 2000, and therefore P will be equal to 1550 newtons.